Welcome back to BAM and Skip. Today we are going to know about ATP synthase. What is it? It is a molecular turbine that produces the ATP during oxidative phosphorylation in the mitochondria or photophosphorylation in the chloroplast. It is used for the energy of proton gradient, that is hydrogen gradient, to rotate and synthesize the ATP just like water turbine which generate the electricity. So let's know the structure of ATP synthase. It has two main parts, the F0 portion that is inside the inner mitochondrial membrane and it acts like a proton channel. It has an alpha subunit that form the proton half channel. There is a beta subunit which acts as a stator that keeps up the part stationary. There is a C ring present, that is a multiple C subunit. They are arranged in a circle and this ring rotate when the proton are flowing. Then F1 portion, that is the matrix side. It is a mushroom like structure. It has beta subunit that catalyzes the site ATP that is made here. There is a gamma shelf which rotate inside the alpha 3 and beta 3 hexamer and epsilon subunit that is a regulatory one. So how it works? So let's know the mechanism. First, what happens? The proton motive force. It have high hydrogen concentration outside the inner membrane space. Lower hydrogen concentration is present inside the matrix. So here the H hydrogen wants to move back inside through the F0 portion channel. So the proton movement cause rotation. First, what happens? The hydrogen enter the alpha subunit half channel, then bind to the aspartate residue on the C ring, and this binding causes the C ring to rotate, and as the ring rotates, gamma shelf it also rotates. So what is important here? The F0 it rotates the C ring plus the gamma shelf. Then the F1 remains static, which is held by the beta subunit. So the rotation changes the shape of the beta subunit. So each beta subunit undergo three states. The binding change mechanism of pole Bohr. It states that if there is a loose bonding, it will be named as the binds ATP plus ionic phosphate. And if it is tight binding, it will form the ATP, whereas if it is open, at that time the ATP will be released. So one complete gamma rotation will form 3 ATP, and ATP is produced with by the ADP plus ionic phosphate. It will bind at the beta state, that is the L state. Now that is a loose state. So gamma rotation will give the beta, which forward on the beta becomes T state, and which will form the ATP synthesize, and then the rotation will continue till the beta becomes 0 state, and then finally the ATP will